Continental rise. Here I have shown you a picture how continental rise is formed. Now if this is continental shelf, this is continental slope, then whatever material is coming from the continent through the rivers or through the glaciers is deposited at the end of the slip or the slope. So the material slips off so quickly and gets collected in this area. This gives birth to a rise. So after continental shelf and slope, there is a small rise in the ocean. This small rise is called as continental rise. It is not necessary that it is present in every ocean feature. Sometimes it is absent, and continental slope straight away meets with plain. So continental slope gradually loses its steepness with the depth. So as we go to the deeper areas, then steepness is lost and a flat area comes. When the slope reaches a level of 0.5 degree to 1 degree, it is referred to as rise. So slope goes from 1 to 2 degree, it is going down to 0.5 degree and 1 degree, then it is called as rise. With the increase of the depth, rise becomes virtually flat and merges with basin. You see? So when we are going from here with the increase in the depth is increasing, and as soon as we reach this area, the rise is meeting with the plain. So continental shelf, continental slope, continental rise, and the plain. Deep sea plain or abyssal plain. Deep sea plains are sometimes such big large areas that they are like plains of the surface of the earth. Deep sea plains are gently sloping areas of the ocean basins. These are the flattest and the smoothest regions of the world because of terragenous and shallow water sediments that buries the irregular topography. Now what is terragenous? It is marine sediments which are eroded from the land. The sediments which come from the land, like terrestrial, the word terre is related to the land surface. So terragenous material is the material which is brought from the land to the sea. So now it says that whatever material is brought from the land to the sea gets slowly deposited in the plain areas and makes the water plain in this area. So it covers nearly 40% of the ocean floor. So a very large part of ocean floor is made by abyssal plain. And the depth here, whenever we are talking about depth of any feature, please remember we are calculating the depth of the feature from the level of the water. I'll show you how. So when we say abyssal plain is 3000 meters, then this is the sea level. So from sea level it is 3000 meters or 4000 meters. If we say this is 60 meter or 30 meter, we are talking about the level, sea level and the continental shelf. If we are saying that it is 300 meters to 3000 meters, then we are talking about from sea level to the base. So please remember, the depth of the features will be counted from the level of the water, the sea level of sea level. Okay, so abyssal plains depth is 3000 to 6000 meters. That means we are reaching the deep sea now. These plains are covered with fine-grained sediments like clay and silt. So whatever is brought by the rivers from the mountains is formed here. I am taking you to a virtual
Welcome
tour.
to a highlight tour of new underwater terrain data published in Google Earth. These areas can now be explored like never before with the publication of the Columbia Underwater Terrain Synthesis, covering an area larger than North America and half of all of the ocean area that has ever been mapped. Let's begin our tour by visiting the Lamont Seamounts. This chain of young seafloor volcanoes has summit craters and calderas, just like their counterparts on land. However, their slopes are pristine, unaffected by rain erosion. Monterey Submarine Canyon and its tributaries form a large subsea drainage system transporting sediment delivered by
This is
rivers
continental
and
slope.
triggered by avalanches on steep underwater slopes to the deeper abyss in high-speed sediment slurries called debris flows and turbidity currents. The California State University at
This is
Monterey Bay
shelf.
has collected new data off
This is
Cordell
slope.
Bank off the west coast of California near Bodega Bay, an area whose fish and wildlife have rebounded since it was made a protected area 15 years ago. The southern face of the 10,000-foot-high Mendocino Ridge exposes the interior of the ocean's volcanic crust.
Mountain range, a
This
ridge
crust was
or a
originally
range.
created 16 million years ago at the axis of a mid-ocean ridge that has since disappeared under western North America. Now let's visit the accretionary prism on the margins of the Oregon and Washington coast. The seafloor of the Pacific Ocean is moving eastward and slides under the edge of North America. Here the softer sediment cover above the much harder volcanic crust is being scraped off and squeezed into folds that produce the bands of ridges parallel to the coast. The Pittman Fracture Zone slices through the Pacific-Antarctic mid-ocean ridge. This ridge formed as Antarctica separated from New Zealand some 95 million years ago. We call these ridges abyssal hills. They are many hundreds of feet high and comprise the primary texture of more than half of our planet's surface. Here we see a 50-meter synthesis of underwater
the
terrain
islands.
around the Hawaiian Islands, curated by the University of Hawaii.
When you
Visit
see them
Winnie Seamount off the
inside,
Big Island.
they are actually the mountains.
Giant squid roam the Kermadec Trench north
The
of New
chances
Zealand.
of formation of so many islands.
Here in the Rift Valley along the Mid-Atlantic Ridge, new ocean floor is being continuously created by seafloor spreading. Molten lava erupts from fissures every few years and then instantaneously freezes into rock when chilled by cold abyssal seawater. Now we can dive into the Puerto Rican Trench, which extends almost 26,000 feet down. Here, the tectonic plate that encompasses North America is sliding past and subducting beneath Puerto Rico and the Virgin Islands.
Such a beautiful subject to study.
Now you can explore on your own using Google Earth.
Okay,
Download
so
the full Columbia Terrain Attribution KML from the Google Earth Gallery to learn more about the new.
this was a virtual field trip for you people to go inside the ocean and see. I can't take you to any place right now to show you places, but it was not possible for us to go on an ocean trip as well. But in geography we have a lot of field trips which I'm missing during online classes. But still, if you want to explore some more about oceans, you can just type this and see whichever ocean you want to see and whichever feature you want to see. Now Google Earth is so advanced that you can see deep inside the ocean also with the help of satellite images. So in the next module, in the next class tomorrow, I will be teaching you about the minor features of the oceans. For today, major features: continental shelf, continental slope, continental rise, and abyssal plain. These 4 features I have taught. I hope you have understood. Have a nice day. Bye bye.